Hello guys, this is Jimmy from Case Group, and in this video I want to tell you about our latest plugin for Maya called Phoenix FD. As you probably know, Phoenix FD is a grid-based simulator that you can use to create things like flames, explosions and all kinds of liquids. When we first released it, it was just a plugin for 3ds Max, but the constant question that we would get is if it's going to be available for Maya and when this is going to happen. So I think this video pretty much answers this question, and my plan for the video is to go over the basic components of Phoenix FD, show you how you can use those, and also give you an idea how to create some basic setups. I'm going to show you how to just burn stuff and just create basic flames and fires. I'm going to show you how to create explosions. I'm also going to show you how to simulate liquids, flowing water with splashes and foam. And of course I'm going to show you how to render these things. So let's begin. As you can see, I've already opened Maya and I have actually installed Phoenix FD. And what it did is that it added a new tab to my shelf here. Now, Phoenix FD is a grid-based simulator, which means that all the simulation takes place inside of a grid. And to create this grid, I need to go to this Phoenix FD tab and click on the first button here. And I'll just create our grid. Now, Phoenix FD is physically based, which means that it's always a good idea to work in some real-world units and to set up your scene in real-world size. So to do this, I'm going to go to the grid options here and set the unit to centimeters. And then I'm going to set one cell size to be 2 by 2 by 2 centimeters, and I'm going to give a size to my grid here. So this is my grid. And then I'm going to need something to emit my fluid. In my case, this will be just a simple sphere that I'm going to create. And I also need something to give me the basic, the initial conditions of my simulation. So something to specify which object is emitting the fluid and what the properties of this fluid are. So I do this by using this Phoenix fluid source. So I'm going to create one as well. And as you can see, here we have the controls for the emission of the fluid. We can control how much fluid we have, the temperature of the fluid, if we have smoke, and we also have several additional channels like UVWs, fuel if we want to burn something, and we can have particles and velocity as well. Before we start, however, we need to specify which object is going to be emitting the fluid, and I can do this by clicking on this button here, selecting my source and selecting my sphere. So right now, if I start the simulation, we'll see a flame going on. Okay, so we have the flame, and I want to adjust a few more things. First of all, I want to make my animation a little bit longer, and I also want to make sure that my grid is adaptive. So we're tracing temperature, we're simulating the temperature channel, and as you can see, my temperature is 2000 degrees Kelvin. So what I can do is I can take my grid and go to adaptive grid and make the grid adaptive to temperature. And now I'll specify a value of, let's say, 1200. So right now my grid is going to expand wherever the temperature of the fluid is larger than this threshold. And as you can see, this red grid that appears is the new dynamic grid that I'm using. Another thing that's obvious, we're tracing temperature, we're also tracing some smoke. And in the viewport we can see a basic preview, but I want to switch off the smoke so I can see more of the temperature and to work with that. Okay, so this is the temperature channel, and let's see and play a little bit around with Phoenix. A cool thing about Phoenix is that all the settings can be changed in real time, or at least most of them. So as you can see, I can play with the discharge, and as I increase it we get more flame into the simulation, and as I decrease it we get less flame. And it's a pretty useful thing because you can very easily get to know and understand the different settings. We can also play with the temperature, and I can make it lower or higher values, and you'll be able to see the difference right away. So let's put something like 2200 degrees, and then we'll move on directly to the simulator. Now, the dynamics of the simulation inside of the simulator are controlled through the dynamic rollout. And the first thing that we have is called wind from movement, And what this does is that if we have an animated object that's on fire and it's moving in a certain direction, Phoenix will automatically create a wind in the opposite direction to blow the flame away. And this is very useful when we have to create many objects that are animated and flying in different directions, being on fire in the same time. And this looks something like this. We can also have this gravity controls here, so if I uncheck it, you'll see that we get the flame going equally in all directions, and if I check it, the flame rises upwards. So basically this is because, as I told you, Phoenix is physically based. So what we have is the temperature of the fluid is 2200 degrees and the temperature of the simulator is 400 degrees. And because the fluid is hotter than the environment, it rises. If it was cooler, it would drop down. And I can have this multiplier for the gravity where I can increase it to make this process faster. So I can make the gravity stronger and the fluid will be rising even faster. Another cool thing that we have is the time scale. The time scale allows me to slow down or speed up the simulation if I want to. And I can even do some cool things like stop the entire simulation, so I can animate the camera or my characters around the fire and or the explosion, create some cool effects like that. We also have vorticity. Vorticity allows me to make the flame completely laminar if I set it to 0, or I can make it more violent by increasing the vorticity parameter. And this is going to be useful when you want to set up liquids, for example. You want to make sure that the vorticity is 0, and when you want to have things like explosions, you may want to increase it to something like 0.6, 0.7. Pressure decay is a value that simulates the effect that the air pressure drops as you go up in the atmosphere, and it's useful when you want to create things like nuclear mushroom clouds. The reason those clouds have the shape of a mushroom is because the air pressure up there is very low and the cloud expands much quicker up there. So I can put too big value. Let's try something different, and you see that as the smoke flame rises, it actually expands in all directions. And this is due to the pressure decay. We can also animate the cooling to extinguish the flame if we wanted to, and drop it very quickly, or we can just leave it to the default value and it will be cooling its natural speed. So these are the things about the flame. We also have some controls over smoke buoyancy, fuel buoyancy. As you saw, we have other channels, fuel and smoke, and because they don't have a temperature, they will not know in which direction to move, so we have the buoyancy to tell them in which direction to move. We also have a multiplier that controls how much the wind and the smoke is affected by forces in our simulation. Finally, we get some options that allow us to randomize the flame, and we have the amount of randomization and how often this randomization is applied. So this is the basics of simulation of flame, and now I want to show you something more interesting, but to do that I'm going to stop the simulation and clear the cache. So let's move to the first frame. So what I want to show you next is a different approach, or a different thing that you can do with Phoenix, and it's a little bit more interesting. I'm going to get the sphere and bring it up there, and then I'm going to create this cube here. So what I want now is for this cube to emit some fluid into my simulation, and to do this I'm going to need another source. I'm going to create one, and in the settings of this source I'm going to do the following. I'm going to decrease the discharge because I want a little bit less fuel. I don't want any temperature or smoke, and I just want some fuel. And then I'm going to take the cube and drag it into this Phoenix source set2, which means that I'll connect this cube to this source here. Next, I'll select my simulator here, and I'll go in the output raw out. In here we have very important controls. We're basically saying Phoenix which channels of the simulation we care about and which channels of the simulation we want to be available in the core. So right now we didn't have any fuel, and even if I started the simulation there won't be any fuel even though we're emitting it here. So I need to check this checkbox here, and then I need to go to the fuel options, enable the burning of the fuel, and give it some energy. So right now if I start the simulation, you'll see a very interesting effect. Okay, this is my fuel, and if I select the sphere and just dip it in the fuel, we'll see a nice explosion. So as you can see, this looks very naturally, very intuitive, in a very intuitive way. We just get something that's very high in energy, and we ignite it, and then we get an explosion. So let's step into rendering. I'm going to hit render, and we'll see the rendered result. And I just did this to show that we can actually render in the same time as we're simulating. But because I want to talk a little bit more about rendering, and I want to talk about the different rendering settings, I'll stop the rendering right now so that we're rendering the same frame every time I change something. Okay, as you saw, when I rendered this out, the whole image was very bright, and the reason for this is that this fluid is very hot, and it's emitting a light at a high intensity. That V-Ray is working in 32-bit floating point, so you can see that we get some really high float values here. Let me bring this over here. So you can see this point has a floating value of like 600 and 250, 400, so it's very high intensity. And I can do something about this. Let's take the simulator and go to the rendering options. And in the rendering options, you will see that we have these three parts here. We have emission, which controls the emissive part or the flame. We have diffuse color, which controls our smoke basically. And we have the transparency, which controls the transparency of the whole thing. And as a matter of fact, we have two different ways of controlling the intensity of our final flame. So what I can do is, for transparency, I can set the transparency to temperature. So now our transparency is going to depend on the temperature. And if I bring out this graph here by clicking on this button, you'll see that this is the temperature of my fluid. This is 300, this is 2000, and I have this curve. And this means that the fluid will be most visible in this part of the temperature, where it's between, let's say, what's that? 1575 and 2000 degrees. So if I decrease this just a little bit, we're going to get a more realistically looking flame. It's still going to be very bright, and this is because even though it's transparent, it's still, the settings for the brightness are very high, and I can adjust those as well. But you can see it's starting to look much more like a flame than before. So I'm going to close this, go back to the settings for the temperature, and click on this button. And now we have this curve, which is rather complex, so I'm going to remove the points I don't care about and set it up very quickly. So let's quickly get rid of those. I'm going to bring this down up till here. So right now we should get something that looks much more like a flame. And obviously I'm just very quickly adjusting these curves. You see that you can add your own points, and you can have much more control over which parts of the simulation are visible and how bright they are and how they look. But let's decrease the brightness just a little bit more, and just for fun, let's change these colors here. So I want a flame that's a little bit purple. I think that's good. And let's say blue here. So right now we'll get a very strange looking flame. But as you can see, it's very easy to set up, and you get pretty nice results very quickly. Now let's play a little bit with the smoke as well. This looks pretty interesting. I just want to do something with the smoke. So for example, I can change the color of the smoke and make it green, let's say. And also I can play with this curve again here, and by changing this curve I can make the smoke more or less transparent. So basically, because the smoke is going to appear in the parts of the fluid where the temperature is very low, somewhere around 300, 400, 500 degrees, by adjusting this curve I can make more or less of the smoke visible, and I can create strange results like this. So as you can see, it's pretty easy to set up, and you have insane amounts of control here when you're rendering, and you can create really nice looking results. So this is what I wanted to tell you about flames and explosions. So now I'm going to move on to fluids, but before that I just want to quickly clear up my scene, and I will pause the recording for this. So, as you can see, I just removed all the necessary stuff from my scene, and now all I left is the source, the sphere, and the simulator. And right now I just want to show you how you can use Phoenix to simulate liquids. So let's do that. For the simulation of liquids, once again we're going to use the temperature channel. And if you remember from the beginning of this video, I told you about the temperature of the simulator being 400 degrees, and everything that's hotter than that rises and everything that's colder than that falls down. So if I set a temperature of 1 degree, I'll make sure that the temperature channel is falling downwards. I also don't need any smoke, so I'm just going to disable this checkbox here, and then I'm going to move to the simulator options. Now the first thing I need to do is go to the simulation options and make sure that I increase the quality here. So if you want to create good quality water, you need to increase the quality of the simulation, because water is more difficult to calculate and to simulate, and it requires just higher quality. So what you want to do is go to the simulation options and in conservation set quality to 40 at least. Then I'm going to go to grid and make sure that the grid is no longer adaptive, so I'm going to disable this adaptiveness. And I'm also going to put some boundaries on my grid, so I'm going to jam it from all directions except from the top. And then I need to go to the dynamics. Then in the beginning I was telling you about the vorticity, and that if you set it to 0 you'll create laminar flow, which is useful for liquids, and that's exactly what I'm going to do now. Then I'll jump to liquids. In liquids I'll say that I want the temperature to be the temperature channel to be as liquid, and that's all I need to change here. And then the last thing I need to do is adjust the preview. Right now for temperature I have set the boundaries between 1000 degrees and 3000 degrees, which means that it's only this if only the temperature is between these boundaries, it's only then I'm going to see it. And instead I want to change this to 0.1, so right now I only see the fluid between 0.1 degrees and 1 degree. And I think I'm pretty much ready for simulating, so let's try that. You see the simulation starting and filling up my grid very quickly. So I'm going to stop this and let's see what happens. Now I'm going to move a few steps backwards and try to render this. Now I can tell that nothing is going to be rendered, and the reason for this is because we need to adjust some of the rendering settings. Right now we don't have any emissive part because the fluid is very cold. It's basically everything is transparent. So what we need to do is we need to create geometry that we can later shade it so that it looks like a liquid. And to do this we need to go to the rendering tab here, rendering rollout, switch on the geometry mode, switch on solid mode, and then specify a surface level. So right now we have just a bunch of voxels, and they have some information in them about the temperature of each voxel, and we need to specify a temperature at which the surface is going to be created. So something like 0.2 should work fine. And let's render once again, and we can see that we have this fluid. Now changing this value will make us see less and less of the fluid, but you can play with these parameters until you create the result that you need. Now from now on, if we want to increase the quality of this simulation and, for example, get those voxels here that are flying away and that are like splashes, as you can see, even with less lower qualities here, we're not able to create nice looking splashes, small splashes. This is because we're limited to the size of the cells, and we cannot render anything that is smaller than a cell. But splashes and things like foam often will be much smaller than the cell size. And if we want to create things like that, we need to take another approach. Because the standard approach would be to increase the resolution of the grid until it's so high that it's impossible to simulate. So what we can do instead is go to liquids, and you'll see that here we have foam and splashes. And these two set of options allow us to create foam and splashes, and to create particles that we can later shade as foam or as splashes. So let's enable those. And before running the simulation, I want to talk about the settings just a little bit, because they share a bunch of common settings. And first I'm going to start with the birth threshold. The birth threshold is basically a probability multiplier for generating those, for creating those particles, and it works like this: if you set a higher value, you lower the probability to generate particles, and if you decrease the value, you increase the probability. So by decreasing this value, I'm making it pretty much sure that I'm going to generate some foam and some splashes in this simulation. Then we have the birth rate. The birth rate controls the number of particles that are going to be generated each time this threshold is met. So because I set so low thresholds for both of those, I'm going to set low values for both foam and splashes. So let's say something like 10, for example. And then we have some controls over the size of the particles that are going to be generated. So I can control their size and add some variation and change the distribution of this variation. Now let's simulate very quickly, and then I'm going to talk a little bit about the other settings. So as you can see, now we'll have these white things. This is the foam, and the blue things is the splashes. So let's go back a few frames. Okay, these are the splashes and this is the foam. And to make it easier to see, I'm just going to go to the preview and turn off the temperature as a whole. So right now I only see the foam and splashes particles. Now before I move into rendering, I just want to very quickly talk about the settings here. They're actually very straightforward and intuitive. The first thing that we have here is the half-life for the foam. Obviously, when you have foam generated in a liquid, those foamy bubbles at some point will pop. This means that our bubbles also need to pop and the particles need to disappear. And the half-life specifies how much time it takes for half of the particles to pop. Then we have this B2B interaction, which stands for bubble-to-bubble interaction. This controls the number of interactions between bubbles, and this will affect the quality of the foam and how they interact together, how they stick together, and so on. We also have rising limit. This controls the maximum speed at which the foam inside of a liquid will rise, and we have a falling limit. If you have foam that's falling like this one here, for example, you can specify a maximum speed at which the foam can be falling down. And you also have this sticky parameter, which controls how much stickiness there is between the bubbles, how much the bubbles stay close together. This is for the foam, and then for splashes we have just two simple settings. We have air friction, which is a multiplier basically. When the particles for the splashes are flying through the air, they'll get slowed down by the air, and this air friction is a multiplier for how quickly they'll get slowed down. We also have this probability here for foam on hit. Every time a particle from the splashes hits the water surface, it can generate some other particles that look like foam, and by increasing this we make sure that there are more foam particles. So this is pretty much the rendering of the generation of particles, and I want to talk about rendering now. But before this, I want to make sure that I stop the rendering of this liquid as well. So right now, if I hit render, we should only see the black screen. Okay, so let's now shade our particles. And to do this, what I'm going to need is to use our own shader, which is called Phoenix FD Foam Shader, and just create one in our scene. Now this shader can be used to shade any kind of particles. It can be splashes, it can be foam, it can also be the particles that we can emit from the source, and it doesn't care what particles you're shading with it. And the first thing we need to do is specify which particles in the scene we want to shade. So I'm going to select the shader and click on this Edit Particle Systems. I'll find the foam selection set here, and then I'll find the particle group for the foam. And I'll just hit render with the default settings. As you can see from Verify, let's zoom in, this looks like some foam that we have. And if it was in something like water, it would look really well actually, and it will add to the realism. But right now I want to be able to see the individual particles and render them so we can see how the settings work. So let's do that. I'm going to zoom on this part and hit render. And right now what you'll see is that the foam is actually formed by small bubbles. And we have a bunch of settings to control the rendering or how they look, and we have also some settings to control the geometry that is created in order to get this look. So first of all, I'm going to give them a little bit larger size so that adjacent bubbles actually interact with each other. And let's hit render. Okay, the first thing that I want to point out is that you get this cellular structure. When bubbles are close together, they actually merge and blend, and there is this interface between them. So this is true because actually our mode is set to cellular. I can set it to bubbles as well, which will generate individual bubbles that are not interacting with each other, not making this interface surface. However, this one looks much more realistic and as a whole better. So from then on, we can also choose splashes, but I'm going to be talking about that in a second, a little bit later at least. And the thing we have here, we have the first thing is the pressure variation, which actually gives random pressures to individual bubbles so that this interface is curved in one of the two directions, either towards one of the bubbles or towards the other. And it just makes the things look more realistic. Then we have three controls that allow us to play with the size of the bubbles that we're creating. So in case we had the particles with the same size, we can control the size and add some variation to that. Now the next option, called subgroup, is very important when we want to render foam especially. So as you know, if you imagine a fuzzy drink or a glass of beer, you would know that some of the foam is on top of the beer, let's say, and some of the foam is inside of the drink and it's rising gradually. And those two foams look kind of differently. So here you can choose which of the particles you want to shade. You can either shade all particles, you can shade particles that are inside of the liquid or outside of the liquid. And this way you can slightly tweak and have different shaders for the foam that is on top and for the foam that is inside of the actual liquid. And then here, when we're talking about geometry, we can specify whether or not we want to have V-Ray, motion blur. First of all, you can let V-Ray decide. So if you have enabled motion blur in V-Ray, you have motion blur for the foam and for whatever particles you're shading. And then you can also force it on or force it off. Now let's take a look at about the actual shading part. You'll see that our bubbles look a little bit plastic. This is because this is the simplest method of rendering them. As you can see, they're semi-transparent. They have a diffuse part, which is this color here, and they also have some specular reflections, but they don't have any clear reflections. And you can control this by increasing the number of bounces here, which will make them more realistic. They will have clear reflections and refractions, and as a whole will look better. However, we don't really need to have this amount of calculations when we're rendering foam from far away, because nobody is going to see that, and it will just slow down the rendering. Instead, what we can do is have this to 0, and the bounce is set to 0, and only use bounces when we're rendering a close-up of individual bubbles or something like that. So if you're rendering a soap bubble, for example, you would increase that, but otherwise just leave it to the default, because as you can see, it requires a lot of tracing. Then we have this reflection cutoff that will allow us to stop any reflections rays once a certain importance is reached, while the importance has dropped to a certain threshold. We also have the refraction index, which is basically the index of refraction of our bubbles, and we have multipliers for the diffuse part, multiplier for the highlight part, and we can also spread out the highlights if we want to. Also, if we want to, if we're rendering a lot of small particles that are very, very tiny, we can turn them into fog and render the whole foam as a volumetric fog instead of rendering all those individual particles. So let's now very quickly shade the splashes as well. And to do this, I'm going to create a new shader, so I can show you once more how you do this selection part. So I'm going to select the shader, click on the Edit Particle Systems, and then select the shader here and select my splashes this time. So Right now I'm using this shader to shade the splashes, and if I zoom in, you'll be able to see that I'm not lying actually. So here are the splashes, which right now don't look very much like splashes. They look more like bubbles, and the reason for this is because the mode of the shader is set to cellular. Let's set it to splashes, and once again I want to increase the size of the bubbles just a little bit so they're more clearly visible, and I'll hit render. And now you see that we get this sort of glass balls, glass spheres that are very reflective and also very refractive. But right now again we don't have any reflections, and you see the bounces parameter in action right now when I increase it to something bigger, because this will begin to look much better than before. Of course, once again this will slow the rendering a little bit, but it will create this glossy feel where the bubbles are reflected in each other and they look more realistic. Other than that, we have pretty much the same settings, and you can use this shader in these two modes to create particles and to shade particles and create really nice renderings in the end. As a whole, however, I think you agree that when we're dealing with splashes and foam, we generally will be looking at them from a distance. We won't be able to see the individual splashes, so we can render them from far and render them very quickly without having to trace any bounces whatsoever. So this pretty much concludes this video. I hope that you found it interesting and that it will be useful to you. I thank you for watching, and see you next time. So until next time, I'm Dimitar Krstev Jimmy, and I thank you for watching.